Hello and welcome to the Craftman Show. My name is your host, the Craftman. The Craftman. In today's video, can we make a 3D printed injection mold? Alright, so when I decided to get into injection molding, I was very excited. I said, baby, we can save up enough money to get us an injection mold machine right there. And we can buy the plastic pellets and we can begin making our little toys and extra figures of things injection molded. That would be faster than resin casting. Also would make a tougher piece. You know, your parts would be more resilient, you know. I said, it's just a win-win all the way around how you look at it. But then I realized, Craftman, you got to make the molds for your pieces. I don't know why I got my notebook out right there, but let's see. Now this mold right here made from aluminum. And that's the kind of pieces that comes from that mold. Now, since we using plastics like polypropylene, polyethylene, thermoplastic elastomer, there's so many different kinds of thermoplastics we can use. Since we're not using polyvinyl chloride, aka PVC, we don't need to make a steel mold, all right? That's what they make in China. That's what many of your figures from childhood was made from, you know, Dino Riders or the little bear from Star Trek. So aluminum molds is going to be cheaper. We talking hundreds of dollars versus with a steel mold, thousands of dollars, all right? If you can have you an aluminum mold made, go ahead and just do that, baby. And then you're going to get so much mileage out of your mold. But what about situations like Craftman might want to make just a limited run of a little figure over here, and they might want to make several pieces for a figure, maybe a leg and an arm, and we can finally do that 3.75 inch figure. I said it would be wonderful if there's a way to do rapid injection mold making. And I have tried various ways to do injection mold. I made one with silicone. Now silicone does hold up to the heat. The issue is it's flexible. And I have found that you can get your thermoplastic squirt in there and then thermoplastic come right back up out there. You could just take you a mold frame right there and use you some heat resistant putty. Look at that. Alright, that will give you a rigid mold. I even have tried doing resin mixed with iron oxide, iron particle, and that actually worked a little bit, to be honest with you. But I still ran into a mold warper, and on top of that, it was a multiple steps process. You had to design your mold, and then make a mold of that mold, then make a cast of that mold, and it just got really involved, you know. And I did try 3D printed molds right there. But you know, it was pretty brittle. And then I was introduced to some specialty 3D print resins that's designed for high heat. Siraya Tech right there. Look at that. So ladies and gentlemen, the plan for this video is we're going to take and 3D print us a mold that's going to fit right up in there, hopefully, and that will withstand the temperatures of injection molding. But the first thing we got to do is to figure out the dimensions on this mold right here, because I do not know. Now I get these mold frames from LNS Technology. I just purchased that from the website. They also got a bigger size that you can get. All right, there goes the thunder. So what I'm going to do is to just disassemble it. What you will notice about this particular mold frame is it's got an angle to it right there. See that? It goes swoop, like that. That's going to add a little bit of complexity to our 3D print. That's actually beneficial though, because it keeps that from just popping out on you. And I remember why I brought that notebook with me. Craft man, you do a precision work right there now, baby. I appreciate that. Let's see. So with that information, I got on the computer. And first of all, I got in Tinkercad, which is a free 3D software. It ain't really a CAD program. You still working with mesh files, but that's all right because we 3D printing. So, you know, I got up and I just was piddling around with it, getting somewhere I thought I would. And then I realized that little bevel right there. Honestly, I thought I might just would print it out with a cone and just sand it down, you know. But I said, look, go ahead and try to do this precision craft, man. Come on now. And so I actually took this into my CAD program. That's called Shaper 3D, and that's what I use on my iPad. I got this recently because I said, you know, I really need to learn me some CAD. Using Shaper 3D CAD, I feel like I was able to get an even cleaner, nicer result. Once that was completed, I said we need some kind of object to do a test with. And my first idea was to get up on Thinkerverse.com and just download something, you know, simple. Ain't have to be too extravagant. And then I said, crap, man, you could just sculpt something on the computer. And then I said, nah, baby, let's just go download something. Don't worry about trying to sculpt. You got to get a video made. All right, crap, man. And then I started just sketching me out some things, you know, as if I was going to sculpt it. And so I said that little squid looking man that we used before. Do y'all remember that? 1, 2, 3, 4, 5, test. Can you hear me? I could use a version of that and make that on the computer. That's pretty relatively simple, you know. Y'all get the fast forward version of this. I'm not a digital sculptor and I don't have ZBrush, which honestly, even if I did have it, it wouldn't help me because I wouldn't know how to use it. I know that ain't the best, but at least it would be something with a little bit of detail that we can test. So I brought my little mold interior and our little object, little friend right there into Tinkercad. On one side, I put my 1/4 inch little sprue and basically just subtracted it from the mold. I also added some air vents based on these recommendations right here. We talking fractions of a millimeter in depth. Them little escape vents is so shallow and narrow that the air can't escape, but the plastic ain't going to flow through it. Then I brought all that into my 3D print slicer. And this software just gets the parts ready to be 3D printed. But right before I printed it, I remember something. We need to scale that down by about 0.10 millimeters something. What do y'all think? I subtract 0.10 millimeter across the whole uniformity of it. Now we got our file generator and we're going to print it. So now it's time for what people in the industry call the moment of truth. It's time to see if that right there is going to fit in there right there. I can already tell I'm going to have to do some trimming on them edges right there. All right, here we go. It almost made it. Almost made it. I'm pretty pleased with how the sprue hole lines up right there. We got to shave some material off of this, alright? We going to make it like that edge. We ain't going to touch it. We only going to work on these edges right there. But we going to try to sand them down uniformly. Anytime you do something on a bill sander like this, you need to do one side rotate. That's it. That's it. That's it. Never just hold it on one side too long. It's going to wear down on you. Now what I did was I made sure that I did not touch that top edge right there. I did not want to change that or change that right there, because let me show you why. Notice I do not have any registration. I almost put registration on there. Some little dimple and little bumps on it, see that right there? But I decided, you know what, I just leave it like this and let these take care of the registration. Let's just do this right here. So as long as we keep these two flush to this way, flush to that way, things should line up, all right? The 3D print mode need to come out as flush with this metal frame as we can do it, because they need to meet up together, all right? It's so jerry-rigged, I stuck my little paper shim down up the knob. I'm going to go ahead and get some plastic run through this before we try the test mode. And I'm just going to make us a little handful of robots real quick. And now we need to adjust the machine for this bigger mold size right there. Now, I know that looks like overkill with the clamps, but in all practicality, I would jerry rig something, you know, to make this quicker to use. I have been known to jerry rig. Oh my goodness gracious. I just cannot believe that. There, I know that does not look 100%, but baby, that makes me excited right there. Look at that. And just like that, we got a little rubber, a little flexible, or whatever this creature is right here. So I'm going to try another one. And this time, I'm going to give a little more oomph, a little more pressure to try to fill at that mold. Also, y'all forgot to tell me to put mold release in there. We filled out the details, but we got some flash there. That's just about what I'm talking about right there now. And ladies and gentlemen, this has just got me fired up about all the potential that we can do with this. This particular plastic is called Santoprene. I like it because it's rubber flexible. I'm very surprised that we get to the results that we get with the, there's some slight non-fluctuativity. It's definitely like not perfect. It won't be no matter how I do it. But I'm surprised I was getting the results that I got with this. There's some thermoplastic elastomer right there. All right, Craftsman, I see that you can get a figure from that mold, but I need me 20, 30 figures from that mold. How long do it hold up, Craftsman? Don't keep trying to make me subscribe to this. How long do that mold hold up, Craftsman? I was able to crank out quite a many of these. Ain't no warpers, ain't no burn marks, nothing like that on it. To be honest, I was only a little bit concerned with the heat. My biggest concern was, is the pressure going to crack the print? Not only the pressure from just being clamped enough, but the pressure from that thermoplastic come in pushing against the mold. There are different ways it could crack it. And also knowing I did not have this German precision 100% flush to the surface. So then I got the idea to do a second test. Not only was I going to try and make a more precision result, also I said, let's see if Siraya Sculpt work as good as that Siraya Sculpt Ultra White. So I printed me out a second mold. This time I applied me some glue to it and stuck it down flush to the front of the metal frame. Then I got this brilliant side just a Craftsman. You could just cut that off of the. And then I remembered I didn't want to do that. So I just put it on the belt sander. It's probably not the way that I would recommend doing it. You're going to have a chance of scratch and scarring up your metal frame. So, I do not recommend it. And this is how it turned out. So it's definitely way more flush, way more smooth than my other mold I did. And that back right there, look at the, I wanted that to be evenly distribution all the way around for whenever we put that back plate on it, all right? I just went ahead and cranked us out a little handful, and the mold looking like they holding up pretty good. Then I decided I would like to get some color, and I just took a clear thermoplastic elastomer, and you put the pellets in a separate container, and then dump in you some powder pigment. That's fluorescent orange right there, and then shake it, and then it looks like a Cheeto cheese puff, and that gives you a flexible orange figure right there. So as far as the future, I would like to maybe look into a better clamping setup, and might think about 3D scanning, because then I could do my sculpting physical with clay, and then bring that into the computer and make an injection mold of it. One little note right here. The mold had just slight little ridges in it, and the plastic picks up every little detail in your mold, so any little slight gradation right there, the mold lines really going to show up in there, all right? I printed it relatively fine settings. I could print it finer, but the way it works with resin-based 3D printing, a situation like that right there where your mold is laying down, them little ridges going to be more apt to show up, versus if I printed the same mold standing up like that, you would not have the same types of lines in it. It would be a finer, more smoother result. Or maybe at a little angle like that right there. But in my case, I wanted to do it quickly, and that right there prints 5 times faster than that right there, all right? I know this one took longer than normal to come out, but it just took longer than normal for me to make it. That's all. Until next time, I love y'all. Lumber prices finna to come back down. And keep on steady crafting. All right.